What does it smell like in space? Scientists have recently discovered what some areas of space smell like. At the center of the Milky Way, there is a big cloud of gas which contains ethyl formate, a compound that smells like rum and tastes like raspberries. It sounds too good to be true that something as delicious sounding as the Milky Way could also taste so sweet. However, scientists also found other, more harmful chemicals present in this compound, including methane, a chemical released from the rear end of cows. So, it turns out that space may not smell wholly lovely after all, and it actually might smell a bit like the belches of a drunk cow who's recently been grazing on a nearby patch of raspberries. Apparently, moon dust smells of gunpowder, despite them showing no chemical similarities. Often on space expeditions, astronauts would bring residue of moon dust back onto the ship with them, and because lots of NASA astronauts have a military background, they were able to recognize the distinctive aroma. But if you do find yourself on the moon, please don't try and take your helmet off to get a whiff of your surroundings. You'll probably only last 15 seconds in the absence of atmospheric oxygen before you lose consciousness due to hypoxia. You have been warned. Do dead bodies in space decompose? If you ever feel lonely, remember you have around 39 trillion microbial cells, including bacteria, viruses, and fungi that live on us and in us. And as soon as we die, they help our bodies decompose. That's what friends are for. But if, in the unlikely situation, you find yourself floating around in space, there are no bacteria to keep you company. So with no bacteria in space, you'd think that your body wouldn't decompose. However, like an intrepid Trojan horse harboring microorganisms as stowaways, you'll have smuggled lots of bacteria from Earth, both inside and on the surface of your body. If you're still inside your spacesuit, the bacteria would use up the remaining oxygen, rapidly multiply, and your corpse would start to decay. If you are not floating near a source of heat, like a star, then your body could stay frozen for eternity, like an astronautical ice sculpture. Of course, the rate of decomposition would be the last thing to worry about if you were traveling towards the sun. This would accelerate the rate of water loss, owing to evaporation, essentially rendering you a dried out, friendless husk floating towards a giant nuclear fire in the sky. Space dust. What's it all about? William Blake once said that you can see a world in a grain of sand, but can you see a galaxy in a speck of space dust? Well, sort of. Each year, 5,200 tons of space dust fall to Earth. Each speck is invisible to the human eye, but when studied using a specialist instrument, you can learn a lot from it. The specks tend to be composed of rock, metal, ice, and organic compounds, which have been chipped off asteroids and comets, either in large collisions or by micrometeoroids. Imagine cosmic dandruff. Scientists think that dust from meteorites may have been darkening the color of Saturn's rings over time. So just like that book you've been trying to finish for the last 15 years, Saturn's rings are gathering dust. Space dust also forms from dead stars. When stars die, they shed clouds of gas in explosions called supernovas. As the gas cools, minerals condense and form space dust, often falling to Earth. It might make spring cleaning slightly more magical to think that the dust you're vacuuming are the particles from an exploded supernova. Sex in space. Is it possible? Billionaires across the globe have their sights set on space tourism. But if hotels really do pop up on Mars, would it be the ideal place for a passionate honeymoon? The main issue affecting space sex is gravity. On Earth, Newton's third law of motion applies to sex. With each action, there is an equal and opposite reaction. But in space, where there is no gravity, even a light nudge could push someone to the other side of the room. So, you can imagine that a canoodling pair of astronauts could potentially end up bouncing back and forth between the space shuttle's inner walls like a game of human ping pong. One expert has suggested that covering the wall in Velcro could be the answer. One consenting lovemaker is attached to the wall, whilst their partner does most of the work. Another suggested that joint sleeping bags could be the solution, but a spaceship seems claustrophobic enough without sharing a synthetic sack with your crewmate. If you're wanting to mix things up with your partner, who knows? Maybe navigating the complexities of zero-gravity copulation is all you need to relight that spark. Time travel. Is it possible? Whether we like it or not, all of us are time traveling all of the time at a rate of 1 second per second, directly into the future. But physicists do think it's possible to travel even further in time. According to Einstein's theory of relativity, time's flow depends on how fast you're moving. If you travel at the speed of light, you experience time more slowly, a similar feeling to what you get when you're on hold to customer services. The twin paradox helps explain this. If one twin stays on Earth, but the other zooms around space at the speed of light, when the astronaut twin returns, they will look much younger than the sibling, and genuinely will be. Time also moves more slowly when you're near an intense gravitational field. So if you're lingering around a black hole, where there's an extremely strong gravitational field, a few hours may pass for you, but thousands of years will pass on Earth. In fact, time Time moves more slowly on satellites than down on Earth because of this difference in gravitational fields. These same satellites guide our GPS systems on our phones, so now you can blame your Maps app whenever you're running late. Time travel into the past is more difficult. We could potentially move back in time via wormholes. Although wormholes are mathematically possible, they are highly improbable, and they would be microscopically tiny, meaning that they would likely collapse under their own gravity. However, these problems could be solved with enormous amounts of what physicists refer to as negative energy. Ultimately, traveling back in time is extremely complex, so maybe we shouldn't try and open that can of wormholes. Space travel. What does it do to your body? Astronauts often place well in surveys ranking the sexiest professions. But if you think you'll return home from your expedition to Mars looking like a 10, think again. From studying astronauts who have spent extensive time in space, researchers have found that you become weaker, your eyesight worsens, and you might even lose brain cells. As there is no gravity in space, the muscles used to maintain our posture don't have to work as hard at all. After just a few weeks in microgravity, the muscles in our back, neck, calves, and quadriceps can deteriorate by as much as 20%. As there is less mechanical strain on us, our bones start to demineralize and lose strength too. The lack of gravity putting down on their bodies also means that the spine elongates slightly, which can lead to pain and slipped discs. Gravity helps blood flow downwards, whilst the heart pushes it back up. In space, the lack of gravity disrupts the system, meaning that some blood can accumulate in the back of the eye around the optic nerve, which can cause your eyesight to deteriorate. This would be particularly annoying if you only flew up there for the view. Scott Kelly was fired up into space for 340 days, whilst his twin brother, Mark, stayed at home. Scientists compared the results when Scott returned. The speed and accuracy of Scott's cognitive performance did decrease for around 6 months after he landed, possibly whilst his brain readjusted to the Earth's gravity. But in the end, Scott's cognitive ability remained relatively the same to his twins. So much for that desperate attempt to outsmart his brother. So now you know,